Good afternoon, everybody. So thank you very much for coming. We've had some fairly heady talks today on machine learning and text, natural language processing, parallel computing, and some fairly advanced topics that are making my brains overheating a little bit. And it's the end of the day, and I'm standing between you guys and happy hour. So what I'm going to do is actually hopefully it's a little bit lower level in some ways, although it still involves a certain amount of technical. It's surprising in spite of the fact that there's the conceptual different problems that I'll be talking about are fairly simple to understand. There's actually some technical subtleties that I'll talk more about that. I've put my material on my in a GitHub repo. Unfortunately, I've just been told that that's going to be out of bounds for some people with firewall issues here at Cap One. So I apologize about that, but I'll try and see. I just have some sort of fairly simple examples that I'll work through. Let me make up get myself a new shell here. I'll leave that up there for the moment. So I've downloaded, I guess once I've downloaded this, I guess I can unzip this. Oops. Yeah, there we go. And inside there's a collection of files. Let me make sure. So I'm going to be working mostly from a terminal for a little while. And I'm hoping, so first of all, I know there's a few people who've had some Anaconda issues. Has everyone managed to get Anaconda installed? Excellent. Okay. So what I'll be doing, so in my sort of home directory here, I've got a few slides. I'll do a little bit of yada yada with the slides, but not for too long. Just to sort of help motivate some of the issues that we have, and then I will get to trying to do some hands-on kind of exercises, and I'll wander around and make sure everyone can get up a terminal and things like. Sorry, so just before I actually get there, is everyone comfortable with using a terminal or a shell, sort of as? And has anyone never done it before? Okay, cool. Because what I'll do is I'll show a little bit about working with a command line interface, then I'll get into looking at some Jupyter notebooks that we use for, that I have included in the repo there. So I guess I just want to, what I want to talk about is just a little bit about the Anaconda ecosystem, and in particular, some of the core things that some very clever people, I would say we at Continuum Analytics, but that would be overstating the case. It's actually, I don't do a lot of development, and that's some very clever people that I'm blessed to work with. But I want to talk a little bit just about, there's a couple of interesting articles that have come out a little bit, right? So apparently Mahmoud Hashemi from PayPal Engineering wrote this very nice article a few weeks ago talking about how at PayPal they're using Conda for Anaconda, and particularly using Conda for packaging and managing a lot of their very complicated software systems, and it's actually become a very crucial tool for them. And that was it was a real nice thing to sort of see that sort of come up on the side, to see people outside our company sort of like really praising the tools that we've been building. Again, not we. Jake Vanderplas from the East Science Institute at the University of Washington also wrote a really nice piece in his blog a few weeks ago, again, about Conda myths and misconceptions. And I think what he was talking about there are some discussions that occur between people working, who have had some misunderstandings about what conda is and what exactly it does and what kinds of strengths and weaknesses that it has relative to other, and what role it plays basically in Python packaging and in Python software distribution. So I guess one of the reasons that there are some issues there, I guess, comes from the fact that we have a bunch of names that all sound similar. Right? So Anaconda is the leading open data science platform powered by Python. And that at the root of that, there's a distribution that's open source that has hundreds of packages. I think this month we actually broke a record. We actually had over 1 million downloads in a month, which I think is a really cool record. That adoption has been climbing, which is really great. Underneath that, of course, Python is sort of the basis of it, and Anaconda and the tools in Conda sort of grew largely from people working in Python. But it's actually a little broader than that. There's a whole array of tools and the scientific PyData stack, which is sort of really all bundled in. That we've solved some of the installation issues. So Conda is a tool that's included in the Anaconda platform. It's a package dependency and an environment manager, and I'll explain what I mean specifically by those in a few minutes. And mini-conda is another term that sort of is a lightweight version of the Anaconda distribution. It's basically Anaconda with everything thrown out except for sort of a base Python and base conda, so that you can actually download it really quickly and then start installing other stuff as you need if you don't want to have the whole weight of a 300 megabyte download. So it's sort of a small scaled down version of Anaconda. But I guess the thing that I really want to talk about just initially, again, before we'll do some exercises in a little bit, and we'll try and be a little bit more hands-on so we can actually get a chance to do some work, is I want to talk about the problem that Conda actually solves. Right? Because I think that's always a good thing to do with any kind of technology, sort of understand, well, what is it that how does this actually fit into what I need to get done. So, I mean, I think the way that I tend to think of it is that a lot of us, when we're sitting around, when we're spending far too much time in front of a computer in a sedentary kind of manner, one of the problems we have is that we've got to get software installed, and when we install software, there's often libraries and other pieces of software on which it depends. And so managing that process is a challenge. But there's a separate problem as well, that sometimes you actually have to have different versions of a piece of software on your system at once, right? So, for instance, famously, one of the things that is confusing to a lot of people when they start working in Python is the issue that Python 2 and Python 3 are not strictly compatible, and there's very good, solid, logical reasons why the Python core community, the core developers, actually made that decision. And it seems like, it took a little while for me to understand it, and I had some of them sort of sit me down and explain it to me, and I'm happy to go into that, actually, if anyone wants later on. But the point is, these are two actually separate problems. So let me just think about this, just in the context of getting a Word document. Let's say it's called Wordy, right? Someone emails you a Wordy document, and you don't have Wordy on your system, right? So you ain't going to be able to read it, right? So that's sort of one kind of problem that you have to sort of then go and find it, or find OpenOffice, or something of some nature in order to get that, in order to be able to use that data. Another kind of an issue, though, occurs when you've got, say, Wordy version 2003 document that arrives in your inbox, and you actually have Wordy 2010 installed. It's the wrong version. And they're not equivalent, and maybe there'll be some backwards incompatibility, or there'll be some odd behaviors that result in this. So the point of this metaphor, though, is, I mean, this is a fairly low-level and simple idea, but I guess the point I'm trying to make here is that this actually has nothing to do with whether or not you're using Python or R. It's not actually got to do with It's not a problem that's restricted to developers and analysts who are working at a technical level. Anybody, anybody who works with computers in any aspect, common consumers of software encounter this problem just by virtue of the fact that there's sort of different versions of things that float around and change. So I want to think of these as two different kinds of problems. I'm going to call one the missing software problem, where you don't have some piece of software that you need in order to get a task done. And another one that I'll call the incompatible version problem, where you actually have to manage multiple incompatible software versions. Right? So, I mean, these seem to be fair. Again, this seems like a fairly obvious, and my metaphor is very low level and simplistic, but I think it's actually useful to think of it in these simple terms because it keeps us from getting, I think in some of the discussions about pip versus conda and things like that, we conflate issues of that are specific to the Python programming language or issues associated with programming and development with, in fact, something that is a much more general problem that has to do with working with software, working with data in general. I mean, a Word document isn't a piece of is actually sort of a software product or a data product more than it is more than it is an actual piece of software. But so anyway, so we have package managers which solve the missing software problem, right? So when you want to install a piece of software, if you're working in, so Google Play is an example of a package manager for the Android operating system. Homebrew works for Mac, MySys2 for Windows, DNF and apt-get for Linux. And then in the Python world, then we have tools like pip and easy install, which were used for managing Python software packages. Well, still are. Well, pip is anyway. I don't remember the last time I've used easy install. That would have been a long time ago. And in terms of the incompatible version problem, I don't have as long a list. Virtualenv within the Python community is sort of the only one I really know about. I'd be happy if someone else can point me to more examples of this, but this is a way of sort of being able to have different versions of software libraries, of Python libraries that are available, accessible, and usable on the same machine at once without breaking everything. And they do these in different ways. So the point is with environments is it's sort of like having a sandboxed environment, right? So you have one box in which you have Wordy 2010, one in which you have Wordy 2003, and you activate one or the other, and you can have both of them on so that you can actually use whichever documents, right? So you don't have, so the fact that someone has sent you something that's a number of years older, again, this has nothing to do with whether or not with programming per se, but it's really just got to do with artifacts of software versions that still need to be supported in spite of the fact that software moves on. So Conda, in a way, actually serves both of these roles. And this is where it's different than pip and it's different than virtualenv. It's kind of a combination of both. Right? So it manages packages and it manages incompatible versions. And there's sort of two ways that you can do that with Conda. The first, I mean, you can think about Conda install. Again, we'll look in a few minutes. I'll show you how to use the Conda and Conda package management system. We can use that to install software when we don't have software on our system. And there's a command conda install that we would use to install libraries, to install Python, R, various other kinds of things when we need it. And the incompatible version problem is what we do is we use conda create in order to create environments that allow us to sandbox different versions of things for later consumption. Right? So the beauty of actually, again, one of the things that, this goes back to about 4 years ago, really, when a number of people at Continuum actually sort of sat down and thought very deeply about this. And they sort of thought about this package and environment management problem in a very generalized sense. And in fact, it really was not restricted to Python packaging. In fact, they figured that you can actually do this with any kind of software that you have to in which you have to distribute binaries. And so, in fact, you can also use Conda to manage R environments and R packages as well. And so one of the things that I'll show you today is, in fact, how, well, I'll give an example of just playing around with a little bit of R code as well. So with all of that said, let me get, that was my yada yada. Let's try and actually do a little bit of work here. Oops. Okay. Okay, so first of all, are the fonts large enough for everybody? Are the fonts not large enough for anyone? Maybe that's the way I should ask the question. Okay, that's good. All right, so now let me take a look here at what I've got. I've got, so there's the slides that I was just showing you. I've got a directory of notebooks, a directory of source, and a directory of data, right? So in the data directory, I've got 2 zip files and a CSV file. So if I, let me just do a listing of my CSV file. So this is a record of weather measurements from Vancouver International Airport, which is where I live. I'm Canadian. And you'll notice this file has some Unicode characters in it, right? So there's actually a degrees Celsius flag there, character there, and things of that nature. Things like dates, year, maximum temperature, minimum temperature, all sorts of things. And we can go through and look at it. So those are for the year of 2015. So from January to December 2015. So in my directory source, I have a sequence of files that are very simple, small and simple programs that basically do one very simple task. They read that CSV file. They print out the maximum and minimum daily temperature in Celsius and Fahrenheit, because we're here in the US, for every day of 2015, and just spits it out to the screen. This is not a sophisticated data analysis task. However, I've got the program there written in Python 2, in Python 3, in R, and in Python 2 using pandas. And so what I'm going to do is I'm going to actually try and run these, and I'm going to have difficulties because I haven't got my environment configured properly. The point of this sort of very simple illustration that I'm hoping that some of you can follow along with if you've got the files now, is it allows, the point is, if you can think about this as you're sharing work with colleagues of yours within your working environment, within your lab, within your company. And you've got some scripts that you've downloaded from them, and there's scripts that are substantially more sophisticated than these sort of brain-dead codes that I've written here, right? Let me just take a look, right? Less Py3 solution. Oop. Let me change into the source directory. Oh, this is an important point. Let me clear this, right? So I'm in the source directory, and I'll list my Py3 under, oops, solution.py. So there's a function up at the top that changes Celsius to Fahrenheit, which is like the staple of every single computer science book that you've probably ever read. Notice there's a reading a CSV file using, this is not doing it in a very, the very pure Pythonic way. There's no pandas or anything in there. It's not even using the CSV library in the module. I'm not pretending this is great Python code. It's got some Unicode in there, which, by the way, that's also part of the reason why I made this up in this way, because that also illustrates one of the distinctions between Python 2 and Python 3. Right? Part of the reason a big reason for the backward incompatibility between Python 2 and Python 3 has to do with the Unicode standard. Right? If you remember, going back, the first release of Python goes back to, I think, 1991. And Unicode was not released until 95. So certain languages like Java, which came around just after that, we're able to incorporate Unicode for internationalization right into the core of the language very early on. And certain other languages had that features as well. So whereas Python, earlier versions of Python had to sort of stitch together internationalization in an ad hoc manner, and it got uglier and uglier and uglier. And finally, when making the change from Python 2 to Python 3, part of the big motivation to say, okay, we're breaking backward compatibility was to fix the problems with dealing with internationalization with Unicode. Yeah, sorry.
Just a quick question is out of curiosity. So are you trying to say that, let's say, to solve a problem in one single platform, we can use a combination of Python and R using Anaconda?
Yes, we can. And yeah, so we'll get to that actually. Totally. We will. We can make an environment in which we can run our code, right? So let me. Okay. Sorry. So anyway, this has some Unicode in it, and that's going to come up when we actually try and run this. So first of all, well, actually, why don't I take a minute? Is anyone have? Blah. If anybody doesn't have the stuff, the codes, let me just put this up again. Just take a minute and let's just make sure. Has everyone kind of got all of the files necessary for you to go forward? Or does anyone want me to wait? Okay, let's keep going. Okay, yeah. All right, so what I'm going to do, I'm going to try running that py3 underscore solution.py, right? And when I run it, it prints out everything. I think there's one day where there's a missing temperature somewhere in here. Yeah, there we go. There's a missing data one day when I guess the sensor wasn't broken, and there's a try catch in there that catches that. Notice the output is in Unicode as well. It has the Unicode Celsius and Fahrenheit symbols. And it's to be expected that that worked because my Python version is Python 3.5.2. Right? So let me try and run Python on my Python 2 solution. Right? And notice I get a syntax error that comes about just from the print command not being written in a function using parentheses, again, which is one of the annoying things about going from Python 2 to 3. It seems it's not that big a deal, but it is just one of these things that's a little vexing. It's not at all it's not a major issue, but it is still an issue. So let me try and fix this. So the way that I'm going to fix this is I'm going to create an environment. I actually do have a second Python interpreter in here, by the way. Actually, I think I've got, if I do which Python, right, I'm on a Mac. I believe the command on Windows would be what rather than which. And what that does is that tells me the file path on my system where the Python executable is that gets run by default, right? Right. So let me echo my path variable. Does anyone not know what I mean by a path variable? We're all good? Right? So a path is just, it's basically, well, when you execute a program, right, what happens is a program is a file that lives somewhere on my file system, and the path basically is instructions of where to look for a program when I'm trying to run it with my interpreter, right? So it looks through all of those, and since my users teaching Anaconda 3/bin is right at the front of my file path, it finds my Python interpreter in there first, right? There's another one down. I mean, user local bin is here, and I actually do have a Python interpreter in user local bin. In user local bin, there's a system Python that comes on my Mac. Right? So one way that I could manage to have two different Pythons on here is to have an alias for one, like a symbolic link call one Python 2, one Python 3, and then try and keep track of that. And various, Linux installations I've had in the past have done this kind of trick with different versions of software libraries. But it's a bit of a nuisance to have to do things in that particular manner. So let me show you what the conda way of solving this problem. The conda way of solving this problem is to say conda. So conda is again, it's the program that's sort of it's a core part of the Anaconda distribution, and so all of the commands are given with some sort of a verb afterwards, right? So conda create. I'm going to create an environment, and I'm going to give it the name py2 environment. So -n is the flag that stands for name, and py2env is the name I'm giving it. And then I have to specify something there, some package, some interpreter, something I want in there. And I'm going to say I want Python 2.7 in there. So Python equals 2.7. So when I execute this, I get a whole bunch of stuff spat out at me. It tells me these are the things that it has to download. This is sort of the minimal Python installation that you can use to create an environment. And I'll say yes. It's linking all of those. It was very quick because, in fact, I've created this environment a bunch of times. All of the stuff is cached locally on my machine. If you did that, maybe it might have taken a little, it might actually be doing a little bit of network crunching, but not a terrible amount. So, and then when it finishes, there's a remark here in comments that is going to be slightly different for Linux and Mac users than it is for Windows users. And that's because of the way that environments or environment variables are set up in sort of a DOS shell and a bash type of shell. So in a bash type of shell, if I want to activate an environment and create and make my new environment active, what will happen is I will use the command source with the modifier activate, and then I give it the name of the environment. In Windows, you just leave out the word source. You just say activate py2env and deactivate py2env. That's the distinction. Sorry, I don't have a Windows machine on me. I suppose I could run a virtual machine, and then we could do both at once. But at any rate, let me do that. Let's do, before I do that, again, let me echo my path. Right? And at the front of my path is user teaching Anaconda 3. So that's my top level. That's called my root environment in Conda. Right? So, and in fact, if I do a list conda env list, what that does is it lists all of the environments that I have. I've just created a new environment called py2env, and the active environment is highlighted with an asterisk. And notice it says that my new environment is actually created in a directory that's a subdirectory of the Anaconda 3 in my user account. By the way, this is actually something that is sometimes confusing. I know when I've delivered training around using Conda and Anaconda before, sometimes in a lab or in a group, the systems administration people want to set things control all of the software that's installed on the system, because they don't want to have stuff that's a security risk that's going to that's going to actually cause a problem with screwing things up. So they want to have control over that. So they actually try and install Anaconda sort of at a system level instead of in a user account level. And in practice, it actually works better for individual users to install Anaconda in their own accounts, and that way they can create environments and shift everything that gets modified is done within the user's own accounts. The system level Python that I have is still in user local bin. All of the libraries that is connected to are still there at the system level. My operating system does not have to worry about that, and I'm not going to break anything in the operating system by playing around with my Conda environments. That's one of the advantages of having this environment management. And it seems it seems from the point of view of many of us who are, who may not be software engineers, who may not have an intrinsic love of computer science, right? We don't want to, a lot of us, we don't care about installing software, managing versions, and doing all that kind of nonsense. We just want to get our work done. We want to write our scripts, do our analysis, and be able to figure out where we should be hedging our bets, right? We want to be able to make conclusions with our data as quickly as possible, and stuff about worrying about software versions is a nuisance. So one of the reasons why conda is a useful thing to get you to learn how to use, it's worthwhile the investment in sort of the upfront cost in learning this, is that it actually helps you get to working with your data as quickly as possible. I think that's a fundamental mission at Continuum, is we're trying to actually make it easier for people to speak to their data. So, sorry, with that said, I've created my environment. If I do source activate, now unfortunately my command completion doesn't work here. So when I do this, what happens is I get, that didn't give me an announcement there, that's interesting. I have a new command prompt that tells me that my environment has changed. If I list the environments again, I can see that now my Python 2 environment is the one that's active. If I do Python -- version, I find it's a 2.7.12 version of Python. If I ask which Python or what on Windows, I see that it is, again, it's in a slightly different directory. It's in Anaconda 3 environments, Py2 environment, bin Python, right? So I've made a little pocket directory within my Anaconda directory in the top level of my user account, which is where this new Python executable is active, right? Right. So what this allows me to do is now I just type Python and I run that on my Python 2 solution, and that runs as it's intended. If I try that on my Python 3, it's the worst kind of error. It doesn't actually run as intended, right? The output is not interpreted correctly but it doesn't throw an exception, which is kind of a worse form of failure. Actually, I think there may be a bug in my Python 2 solution as well. Let me. No, there isn't a bug. Okay, I thought someone was going to put something sneaky and put instead of writing 9.8, if you write that as 9/5, the behavior is going to be different in Python 2 versus Python 3 unless you import from future the different behavior, the division operator. But hopefully that's something that we'll all be able to forget about someday. Okay. So I've got my Python, again, my Python 2 environment is active, right? Conda env list. So what that does is that lists all environments, right? If I do conda list, that lists available package in my environment. Right. Actually, you're not restricted. I could do conda -n root list, and that lists all the packages in the -n is the name of it stands for name. So this says list all of the packages inside my root environment. Whoops, I didn't like that. I guess maybe I can't do that one. Okay, never mind. I could do it with a different environment, but we'll get there in a minute. Okay. Right. So remember, I still have my Python 2 interpreter. So if I try running that now on my file Python 2 with pandas, I get an import error, right? The import error says there's no such module named as pandas. Right? So if I again, if I do a conda list, I'll find out that I don't have pandas installed, and I can install pandas, right? So this is the missing software problem, right? So the way we install software is using conda install. Just as if we're used to using brew or apt-get or DNF or other package managers in various operating systems, this is an easy thing to do, right? So we do conda. Well, let's do this first. Conda search pandas, right? So what this does is it looks on anaconda.org and it prints out all of the packages that are available with pandas. Notice it doesn't just have pandas. It has pandas available in a whole large chunk of different versions, right? And different versions compiled with Python 2.6, Python 2.7, Python 3.3, Python 3.4, Python 3, you know, all the way down here, right? And different versions of NumPy, because that's a dependent, because pandas depends on NumPy. So this, you know, so this is actually worth, again, it's important. If someone sends you a piece of code that they have developed using an old version of pandas, and you just want to see that you can get the same results that they had, you can use this to figure out, you can use conda install to download precisely the version of pandas that they had used, and then run and get the same results as them. In fact, yeah, sorry.
So when you run that program, then regardless which version of pandas was written in, you recognize you will be able to run the program anyways, right? You have all the versions.
You can create an environment that will have the correct version,
Okay,
right?
So you have to create an environment.
You have to create an environment. So these are not stored locally on my machine.
Okay.
These are stored on anaconda.org. And we'll actually, when we talk about Anaconda Cloud in about half an hour, actually we'll learn more about this and see how we can actually get more packages from remotely. And I'll explain where this all fits together in the ecosystem. But yeah, that's an important thing. So sometimes, and again, I have been some places. I guess I was talking with someone from Cap One a few minutes ago about an aggressive firewall situation. There may be issues with downloading from anaconda.org if the firewall, you know, in your lab or your environment is very aggressive. And some of our clients actually, there is a commercial product we sell basically called Anaconda Repository, which basically allows someone to have, if you've got an air-gapped environment, you can have an Anaconda repository hosted locally, within which people can actually put their own projects and share their own codes and environments for sharing within the company if you've got corporate secrets that you wish to keep. So there are ways around that, but I'm showing right now just the default open source tools that are freely available that Continuum supports. Right, so what I was going to do, so what I did just now is I did conda search pandas, right? And so now what I'm going to do is I'm going to install it. Conda install pandas. Now, if I wanted to, I could specify a version, right? But I'm not going to do. I'm just going to, and then by default, it will pull down the latest version that is compatible with the version of the Python interpreter that I have. Right. So when I do this, it tells me it needs to download a few things. The MKL libraries. Again, I mentioned NumPy is a dependency. Pandas 0.19, that's bleeding edge, I guess. I was just talking, one of my co-workers, I guess, Joris van den Bosch, is a core pandas developer. The ink is still wet on that one. It was only released a few days ago. Date utils, Python time zones, and there's 6, I guess, for, backwards compatible. Oh yeah, and this is all consistent, of course, with Python 2.7, right? So I'm going to say yes. Again, it didn't do the downloading because I already have all this stuff cached on my machine, but you guys might have had to do that, right? Let me clear my screen here. If I do conda list, right, I get a listing of all of the packages installed in my working environment. Remember, my working environment I know is my Py2 environment. And it has all of these things here. And so I can now type Python, Py2 pandas solution, and I get the right result, right? Right. You can take a look at the code. It doesn't do anything. Right. It's nothing fancy. It's just importing pandas at the beginning, and we're doing everything with a data frame instead of doing things with whatever it is we're doing. Instead of using pure Python with file reading. So, and again, I can. So if I do source deactivate, I can do source deactivate without naming the environment, and what that does is that switches me back to my root environment. Notice that it isn't like a context in right. It isn't layered. If you activate an environment and then activate another environment on top of that, it goes back. When you deactivate, you go back to the root. You don't go back to the one that you activated in the middle. Right, so just because all it's doing is it's throwing away, basically it's just changing your path variable. Right, so if I do source, actually before I do that, let me echo my path variable again. Right, my path has py2env bin right at the end. So if I do source deactivate, and in Windows, you would just do deactivate. Right, if I look at my path, I've gone back to my default Anaconda bin. Right. So that means that if I try and run my Python 2 solution again, I get my syntax error, but I can run my Python 3. Right.
So you can have Python 3 installed by default and use it by default, and if you want to use Python 2, you create a separate environment.
Correct.
But you don't need an environment for Python 3 because it's so.
Because that's my default. Now, if there is a version of Anaconda that's Python where Python 2 is the default in the root environment, and then you have to create an environment for Python 3. But thankfully, I think we are moving toward a world of Python. We've got what another 4 years in 2020. Python 2 will no longer be supported officially by the Python Software Foundation. So, sorry? Is anyone here still using a lot of Python 2? I guess a lot of people are. Yeah, it is taking a while. There are ways to learn to program Python 2 in a Python 3 kind of style, and to kind of wean yourself off of it slowly. There's certain things that are nice, but there's some nicer, more elegant aspects of it, but it's a nuisance sort of having to go back and forth with them.
Some libraries are in Python 7 or better. Working on social media, for example.
Yep.
And the libraries are better in 2.7.
There are some that are slow to being ported, but a lot of the really important ones are like NumPy, SciPy, Pandas, scikit-learn. All of the scientific data stack. Everything is in you can get in Python 3, right? Python 3.5 now. Okay, the last one, of course, I've got is my R solution here, right? And so this is my first program in R. I don't know R at all. I just figured out as much as I need. I did enough sort of Stack Overflowing, Googling to figure out how to write something that is R-like that would actually solve this problem. The one thing I had trouble was just figuring out how to get the Unicode right in R, because I didn't. That took me a little while. The rest of it was fairly straightforward. And of course, the Pandas data frame is all based on our data frame, so of course that part was easy. But anyway, if I type R, command is not found. This is the missing software problem. Right? I'm trying to execute a program that I don't have to run that source code that I have, but I don't have the asset on my system. Of course, I think it's RScript is the tool that you would use to run that. And of course, I don't have R script either. But conda can come to the rescue here, right? So conda create, I'll give it the name R environment. Now, I have to do something a little different, because if I say R essentials in here, I think it's going to tell me it's not going to find it, right? Oh, it did find it. I may have, okay, hang on a minute. Conda config. No, what did I want? I wanted it to, can I do show? Yeah, there we go. That's why that happened. Okay, I didn't explain this, so if you guys might not have had that work. And let me explain why. By default on anaconda.org, on Anaconda Cloud, I should say, there's a repository that contains a whole whack of software packages. At the same time, there are basically directory paths within the repository where all of these software packages are stored that are called channels. And we're going to, when we create our own anaconda.org accounts in a few minutes, you'll create a channel of your own. But there's one that's called R, and mine is apparently, my conda in this account is configured to search the R channel. Yours might not have been. So let me, whoops. So let me do the command as I should have done it. So conda create -n, well, let me say -cr. So that says use the R channel on anaconda.org. Let's give it the name R environment. And then let's ask it to install R essentials. By the way, this will still have Python in there. But what it'll do is now it'll find the metadata. Whoops. Yeah, okay. Oh, actually, this looks like it has to... Oh. Maybe there was an update since I ran this 10 minutes ago. Oh, no, it only had one to download. Good. So now it's extracting all of these. It's linking them. Right. And again, now I have an R environment. If I do conda env list, I can see that I have 3 environments now. One that's called py2env, one that's called renv, and one that's called root. And the root one is the one that's active, as indicated by the asterisk. I always say asterisk instead of asterisk, but because from the comics. Anyway, what was I doing? Oh yes, right. So now we should be able to activate that.
Since you only have one R, won't the R program run even if you don't do the activate?
But it was not, so the point is, well, hold on a minute. So you're asking if it would run if I don't, so right now my root directory, my root account is active. So if I type R script now, right, I get it's not found. If I type R, it's not found. And the reason why is my path variable. Right? My path variable has Anaconda bin at the top.
Okay.
Right? So what will happen is now I will activate, let me clear my screen here. So if I do source activate R environment, I don't know why it's not giving me the message about that, about prepending. I must have done something to my config. Anyway, so now if I do which R, it's in anaconda/envs/rn/bin/r. So that's why it didn't run just before when we tried it, right? Because this directory was not in my path. And now it's at the front. Right? So that means if I type R, I get an R interpreter that comes up. And I can do things, whatever things people do in R. I'm sorry, I'm not bad-mouthing R. I certainly, you know, you get the computer people, computer scientists, I think, sometimes get really bad about that. You know, these language wars. When I was in grad school, I was the only person in my department still programming in Fortran. In a computer science department. I mean, it's not like I didn't learn C and C++ and Java and all those other languages, but I was working with scientific codes, and that was a practical tool. But then you'd always, you know, and so all the other kids would, you know, they'd make fun of me and beat me up and take my lunch money, and they didn't do that. But anyway, I always, the whole, you know, my language is better than your language it's silly, right? I mean, I think the truth is, you know, data scientists, analysts, engineers, various people, you know, you want to get your work done, you work in whatever language you need to. If you can find tools like Conda that can help you find a way to make these codes interact with each other as smoothly as possible, then we can all get something done, right? It is nice to have a common code base. I understand that, but part of the reason why I think Conda and Anaconda has done well, I think, one of the valuable things, I think, was when my colleagues developed it. Initially, it was a Python thing. It was supposed to be solving the Python packaging problem in the same spirit that pip and virtualenv did. But they sort of abstracted it and realized, well, wait a minute, this isn't really a problem to do with Python. It's a more abstract problem about just managing binary packages in general. So let's actually lift up the environment in a way that we can actually support other languages. And so now other open languages like R and Scala, you know, and Julia in principle, Ruby, you know. I'm not sure that we actually do support all of those, but certainly R and Python are the ones that there is a lot of effort going to, simply because that's, you know, those are the ones that real data scientists and real analysts want to have at their fingertips, right? So now I can type R script, R solution, and I get it to run, right? I haven't checked that any of this is correct, by the way, or anything like that. But so I mean, we shouldn't necessarily trust these. You know, software quality is another, and testing frameworks is another matter entirely. However, I think that I think that there's something really valuable in what we've just illustrated. Right? We can take 4 ridiculously simple programs that we weren't able to download, run, get working immediately, and now we can, right? That's a powerful thing to do. Moreover, actually, I think we could even do this within the context of Jupyter notebooks, right? So let me and let me go to.
Is it not easier to just install that library at the past?
Well, no, but the problem is that you can have conflicting versions on your system. So you want to be able to do it in a way that's clean. Sorry, the question was, is it not easy? It's, you know, the idea of activating and deactivating environments is kind of messy. I mean, so the other thing to realize, of course, is that, I mean, I'm doing this within the terminal window. But I could actually have 2 terminals, right? Conda, source activate Pi 2 environment, right? And here, of course, I'm in my root environment. No, I'm in my R environment. So I have two different environments active in two different shells, two different terminals, right?
But then I have to remember which shell is what.
That's
Saying if I do a clean install of Python 2 or 3, do I still need conda?
so I mean the issue is if you actually need to have both, right? So I made the metaphor of the Word document, right? Word 2003, Word 2003, and Word 2010, right? Someone sends you a Word 2003 document. I want to be able to read the document that they sent me, but I also want to read the work that I already have. So the problem is that if you say, yes, I do a clean install and hope the old version goes away, that's fair enough if the old version does go away. But if you actually still have to keep different versions of libraries around, and it's not just Python 2 and Python 3. It could be Pandas version 0.16 and Pandas version 0.18, right? You can have, and if you have a large enough code base that is, you could try and port everything forward and make sure you keep all of that ready. But if you just get something, if you're sharing things that you're getting from other people all the time, it can be tricky to do that.
Can you also track the performance of the programs that are running, like, where they stand, to track the programs?
You mean profiling?
Yeah, exactly.
You could certainly run a profiler in any of the. I mean, I guess there's profiling tools in Python that you could employ, and you can download those. Yeah, I mean, you can download the relevant libraries or extensions within the environment. So,
Excuse me.
yeah.
Is there anything similar to the virtual environment wrapper?
So virtual env.
Something's a wrapper, so instead of saying like storage activate, say R, you just say work on?
You could define a macro that has that effect if you needed to. But so he was asking if is there a shorter macro kind of way of activating environments. There are a few things that we can do. Let me see if I can show you one of them. But before I do that, let me point out a few other things that are relevant. So one thing is, so we can export an environment, right? So export -f py2 env.yml. So what that does, so this is, remember, this is my my py2 environment list in the green terminal window, and these are all the packages that are installed in there, right? So in fact, it turns out, I just, when I did this export command, by the way, let me see if I can do this. Using get started, where is the, there we are, conda cheat sheet. There's if you find the conda documentation at conda.pydata.org, there's a conda cheat sheet which very nicely summarizes a lot of this stuff. You don't have to memorize all this stuff. It's all well documented. So I know I'm sort of bringing it out. I'm going to show you in the files that you just downloaded from me. There's also some Jupyter notebooks. I'll open those up and we can go through those a little bit too. So I just exported this this YAML environment to a YAML file, right? So if I do ls-rt, whoa, oh, I'm in the wrong directory. Okay, never mind. Right, let me do less py2 environment.yaml, and this is a YAML file, right? Yet another markup language. And it summarizes the environment that I created that I was able to use to run that program. So this is very useful because what this means is when you write a program and with whatever versions of software that you're using, and maybe it's the latest version of everything, but it's only the latest version for about 5 minutes until someone releases another version. Right, so when you're writing a program and you have it running in it and it's producing results at a certain with certain versions of libraries, you can export the environment to the YAML file. So when these files that I showed you, these 4 silly programs, Py2 solution, Py3 solution, Py2 pandas solution, and so forth. In principle, assuming those were files that I had shared with one of my coworkers or maybe a colleague in from a different lab or a different company, I downloaded it from the internet or something. If someone had shared the code but also shared the YAML file describing the environment, then that means I would be able to reproduce the results immediately. I could create an environment and immediately run the program, right? Which is a really big time saver, right? If you've ever downloaded someone's code and struggled to figure out how to get it to work, and then tried to figure out how to install the versions of libraries that were compatible, but then you had the problem that when you installed the versions of libraries that were compatible, it overwrote the library that you needed to get your own work to work, right? So the idea of environment management actually can help you get to the point of reproducibility.
What you're suggesting is mostly useful when we are sharing things with each other and leveraging each other codes and sort of more of a sharing community.
Absolutely, it's a very so.
It's not so much for individual use, but more for like community. I understand there are advantages.
Yeah, well, I mean, but even not even just so. So the comment was made that it's mostly useful when you're sharing with a team. But I would say it's even useful when, suppose you're just trying to learn some new tools, some new library, and the developer or some other analyst has put up some sample code or a Jupyter notebook, and you want to run that Jupyter notebook, but you might actually have to create an environment in which you could create a vanilla environment and just keep adding packages until that code runs, right? And then when it runs, then you've actually got everything working smoothly.
So what you were saying that let's say someone has something Seaborn, right, and I don't have Seaborn backend.
Correct.
I use Anaconda, I can just create an environment right away.
Correct. And if they've distributed a YAML file that described the environment where their file worked, then it's absolutely no time for you to work that out. And that's one of the things that you can do on anaconda.org, on using Anaconda Cloud, right?
Do you ever get any issues where when you're sharing the YAML file with someone else, but they're in Windows, and you have to create it in Mac?
Actually, that's the nice thing is that if these things have been created appropriately, and if there are, so the answer is generally speaking, a lot of the stuff on Anaconda Cloud actually does have Mac, Windows, and Linux versions. So these files here, these dependencies here, list software versions that should have been built for all 3 of those operating systems. So you should be able to do that. Now, it may be that someone has created a library and they were working on a Mac machine, and so they've released this software, and there's a conda package for the Mac channel, but not for the Linux or not for Windows. So that can happen. But generally speaking, most of the stuff on Anaconda Cloud is going to be platform agnostic. But thank you for asking that question. That's a very important point. But this is like a huge advance, right? I mean, like the idea of reproducibility in software, in computing, is a tremendous problem. Right, there's so many. I mean, especially in the scientific community, right? There's a big push about this in scientific research communities because scientists of so many different flavors are publishing papers based on computational results, and no one else can actually figure out exactly what they did. So unless they share their codes, and unless you can actually recreate the same environment that person did when they published that paper, you're not going to be able to do it. You're not going to be able to reproduce their work and actually verify. And that is a really frigging annoying thing when you're reading a scientific paper, right? I remember that from grad school. I used to supervise graduate students at one point in my life, and that was a painful thing. You realize that that there'd be some poor young person who's spending most of their 2 years as a master's student just trying to get to the stage where they can reproduce something that someone else has done in another paper. Right, I see people sort of, laughing and nodding in the room. It's certainly, and it would be so. And sometimes they can't reproduce it because there's problems in the paper that you don't know about because they haven't released the code. Right. Anyway, that's a sermon for another time. let's actually let's go one up. Okay, so let me change in my notebooks. Do I want to do that? Let me just do this. Let me do this here. Right, so Jupyter Notebook. I'm in my root environment. In my root environment, I have a Jupyter Notebook server, so I should be able to create this. And if I look in my notebooks, there's a whole bunch of things here. Actually, if I go back to the notebook dashboard, I'm running, I think you may have this too if you've downloaded the latest Anaconda. There's actually a way, this actually points to the question you were asking me about switching between environments without actually having to do the source activate, source deactivate, if there's some shorthand of doing it. So the Jupyter Notebook extensions provide some graphical ways of doing this, right? You can actually, we can actually launch, we can create new notebooks. Oh, it doesn't actually have all of my environments in there. And we can actually switch between these environments, or at least find out more about them. And modify them, search for things. I think we can even install things in there as well. So we can modify environments from within our Jupyter notebooks. So, right. So here's I was doing a lot of yada yada yada. I was trying to get us to be doing some hands-on mucking around with the keyboard. But if you want to have some notes that you can refer back to summarize all the stuff that I've talked about here in the tutorial, a lot of this stuff is contained here in these notebooks that my colleagues and I have sort of made. In fact, yeah, so I think actually, so the second one here actually does exactly what we just did there, right? We created conda environments in order to create a Python 2 environment, in order to create a Python, an R environment, in order to create an R environment down at the bottom. So why am I telling you this? I'm telling you this because if you were wringing your hands, cursing my name that I was typing all of this stuff so quickly and you guys didn't get it to work so quickly, all of it's here in the notebook. You can find this stuff afterwards if you want to go and read it again later. Okay, so let me close these and halt. So there's some more things we can do. Let me just point out how much longer, let's think, what do I have? I started at 4:15.
17 minutes.
17 minutes, okay. Wow. Okay, and it's happy hour. I know, okay, let me, well, you know what, I'm not gonna go through. There's all sorts of stuff in here about adding stuff, modifying environments, right? We know how to install, you can uninstall, you can delete environments. All of these things, you can look at the conda cheat sheet and figure these things out. You can look at the documentation. But the one key lesson I want you to walk away with today is, what problem does conda solve? It solves the idea of, it solves the missing software problem. So when you want to be able to install software smoothly, it serves as a package manager. But it also serves as an environment manager, which allows you to have mutually conflicting, incompatible versions of software existing on the same system in a way that doesn't make everything barf. That's the big lesson. Yeah, sorry.
It's a pretty fundamental question, but what's the difference between the pip install and the conda install?
Oh, that's a deep question. So no, it's fair enough. So first of all, I mean, so traditionally, pip was only pure Python. Right, so one of the reasons that conda was developed is that people who were working with the scientific Python data stack, they needed to be able to install things like NumPy, SciPy, Pandas, which not only relied on Python, pure Python, it actually was also had C, some other code that basically then led to machine-compiled executable library, executable code that was binary that was dependent on what system you were running it on, so it was a more difficult problem. Now, PyPy and pip eventually set up a system called Wheels that actually helped solve this Python. This helps distribute precompiled binary executables rather than compiling everything from scratch. It used to be that pip would actually compile everything from scratch. So that difference has actually changed over the years. However, there is still the issue that pip is strictly for Python packaging, right? Whereas conda, because it was sort of built after the fact, and people had an opportunity to look at the ecosystem in a slightly different light, is now language agnostic, right? So you can actually use it for more broad class of tools. No, thank you for the question. Sorry, I should have repeated the question. He was asking me what the difference between pip and conda. Sorry, I should. That's always a thing when you're recording. You have to remember to repeat the question, and I always forget to do that. Okay, but thank you for the question. Okay, there's more stuff here about managing environments. One thing I want to do before while we are still here, and maybe actually we can do this as an exercise. I want to go to anaconda.org. Okay, and I'm going to sign in. You guys can create an account on your own if you want. I am blessed. My mother chose an unusual spelling of the name David when I was born. And it is sufficiently unique that I'm able to use it as a login ID everywhere. Even my Gmail account is Dhavide@gmail, right? Which they don't even let you do that anymore at Gmail, right? Because I was one of the, back in 2007 or whatever. I was one when it was still beta testing. Anyway, so I'm easy to remember in that way. So don't say your password out loud when it's being recorded. Okay. So here's some record about all sorts of stuff that I have on anaconda.org. Let me go back to my notebooks. There's some stuff here about more stuff about working with conda environments, about creating conda packages. And again, that is you can read the documentation about that, but you can go through some exercises in there that I think are fairly self-explanatory. They're really nice to read. I think it's not bragging because it's actually my very excellent colleagues who are trainers at Continuum worked. We put some of this stuff together and to make some exercises, and I think the narrative flow is very nice and very clear. So let me get these guys to shut down for a minute. But one thing that I was going to suggest that we do, I was going to suggest that we each, let's say on the basis of whether or not our surnames are in the first half of the alphabet or in the second half of the alphabet, we each upload a different IPython notebook to our anaconda.org accounts and then try and share it with someone else. So what I had intended to do, I didn't realize I guess I had too much material, but that's okay. I was going to leave these as exercises for people to do to solve. Suppose I give you guys as homework solving this goofy problem with pandas, right? And it's one of these things that's probably I probably stole it from Wes McKinney's book, and Wes McKinney got it from the R people as well. One of these baby names problems with the baby names data set, right? And there's another one there with the movie lens data set. So you see these all over the place. But let's say, I was going to say, I'll just do something and then put some work in there and then let's try and share it. But let's just forget about the solution. Let's just share the notebook as is. So what I'm going to do, okay, so I'm going to change into the notebooks directory. So my surname begins with an A, so I'm going to upload, and I think I do Anaconda login, right? Again, my unique first name. Don't say your password out loud. Oh, it seems like I'm already logged in. Okay, I'm not going to do that. I guess I already have something there. But what that is going to do is that's going to allow me to use, if you, by the way, you might have had to do, yeah, okay, I've just killed these things here. Let me go to the documentation here. Anaconda Cloud is the big thing that we're doing here. I've got about 5 or 10 minutes left, but I just want to do this right now. So if we go to the quick start, we'll see sort of the basic principle. So you might, so first of all, you might have to do this first. You might have to conda install Anaconda client. If you hadn't done that, then you wouldn't be able to do the Anaconda login that I just did, right? Oh, I guess I do have that. I wonder what environment that was in. Okay. And we can build and upload packages. Let me show you how to share a notebook. Right? So, ls baby, yeah, there we are. So I will do Anaconda upload babynames.problem.ipynb. Oh, whoops, I misspelled upload. Okay, so it's done. Oh, now it's done. Upload's complete. And if I go back to my dashboard here, and I view all, I actually see I've got that notebook there. And actually, if you guys do a search on Anaconda Cloud, you should find that. You search for baby names problem. Oh, notice it's gone and lowercased everything. I wonder if that's a Mac OS thing. Maybe that is. Anyway, that's something just to be careful of. I'm always I've worked with Linux systems for about 20 years, and Linux, of course, is very strictly case sensitive in names. So I got in the habit of naming things with similar names but with different case. And then I started using a Mac and ended up clubbering my files all the time. So I have to be careful about those sorts of things. But I guess if you're Mac and Windows people, but if someone else actually, so I said my surname begins with an A, and I chose the baby names. If someone has a surname that begins with M to letters M to Z, and they can Anaconda upload the other package which I had there, which was the movie lens problem. Let me see if anyone has done that. No one's found that yet. Why don't if someone can actually, has anyone created an anaconda.org account yet? All right, could you give it a go? Uploading the movie lens.
Can you give me the syntax we upload?
Yeah, sorry, of course. There you go. Anaconda upload foo.ip1b. So, once, oh, sorry, I'll leave that there. What I was going to say, we can upload IPython notebook, Jupyter notebooks. We can upload environments. We can upload conda packages. So I didn't show you how to create conda packages. That's described in the Jupyter notebooks. It's described in the documentation. It's actually not. It's actually fairly simple. Depending on how, I mean, it's simple for. I mean, if it's pure Python, it's very simple. But if you have binary files that need to be compiled, and then you have to worry about different versions for different architectures, and then it gets more complicated. But it can still all be managed. But again, I think the cool thing is we've set up is that there's a framework that has been set up to smooth out the package distribution problem in a way that is different than has been done by PyPy and with using pip. So let me take a look now and see if anyone has done this. And there we go. We've got a few people here, right? So I can go to Brian Fuller's right there, and I see the whole thing. I can download it. You can control all of this as well. Let me go back to baby names. Right. So I'll go to my version. Now, you know, what I can do is if I really don't like, you know, because this is a toy problem, if I go to settings and I go to admin, I think I can actually transfer this to another owner, or I can delete it. So I can actually get it off my account there if I don't want this. And just to confirm that's what I want, baby names problem. Right, and now I don't have that there to share. But you can create all sorts of things and share them with people. You can, and by default, on Anaconda Cloud or anaconda.org, everything, the accounts are free, and you know, as long as everything's public, it's similar to the model with Git, right? If you want to have things that are private, then you have to pay a little bit for extra storage and things like that. This is basically all a public-facing Anaconda repository. So businesses can purchase Anaconda repository from us and then have their own private storage for sharing their own work within a company, right? So, but at any rate, I think I've got about 2 minutes left. So I think that, and I'm losing my voice. So I better, if anyone has any questions, I'm happy to answer them. We can, but why don't we call it a day and figure out how we can get to happy hour? Thank you all very much for your time.
Thank you.